Oh, does anybody remember? What's the top node? That's a compilation, right?
Goal in compilation.
Well, goal is the top node, the top rule, but it creates a compilation. So, what is a compilation? That's also just a non-terminal. But what does the compilation contain?
Sequence
of. You're right.
Interface? No.
Sequence of class decals, right?
Yeah.
Right. Because we use class decal for interface as well as for class. So, so you can imagine we have something that looks like this, and we traverse this tree. Then already at the second level, we'll find all the class decals. I can't have nested class decals, so that the tree will look like this. And what I do is every time I hit one of these class decals, I throw it into this global symbol table by its name, and the value is going to be a reference to the class decal. So that's going to be a reference into the tree here somewhere. And then what I do when I've done that, then I initialize the field table and the method table that I have inside the class decal to empty, and then I keep visiting children down here. So this class decal might have a method decal, field decal, and whatnot. And once I hit one of these, well, if it's a method decal, then I shall insert it into the method table. And if it's a field decal, I want to insert it into the field table. Right? So I can go through the tree, left to right, depth first, and fill in these tables. Right? So by the time I've done that, I will have a structure that looks like this. The only thing we've got to figure out is how does this symbol table work? So how do we put things in? How do we get things out? Which is something you could probably write in 5 minutes because it's a wrapper to a hash table. So not a big deal. We have to figure out how to traverse the tree then. How are we going to traverse a parse tree? Do you remember writing tree traversal procedures in other courses?
Yes.
That was pretty easy, right? How do you do it?
Well, there's a lot of different ways.
You can either do it recursively or non-recursively.
Yeah. Recursively would probably be a good idea.
Yeah.
Is it
Definitely.
also order? I can never remember.
Well, I want a. It really doesn't matter. Well, it does matter because you have to put this class decal into the table and update your references before you start bunging things into it, right? But that's minor detail as well.
So
when you hit the class decal, you put it into the class table, and then you might have some global pointers or something that points to these two tables so that they're easy to get to, or you have a global reference that points to the current class, and the current class has access to these two. So every time you hit a method decal, a constructor decal, or static initializer, you throw things into here, and every time you hit a field, you throw it into there. So we could sit down and we could probably just write a traverse procedure that said something like, if, well, maybe it would look something like this. If node instance of class decal, then do something, right? Then cast it to class decal and then start doing things. But we're not going to do that.
We'll use a visitor.
We'll use a visitor pattern. The visitor pattern is hella complicated, but very nice to work with. So we kind of have to talk about that, but I'm okay with doing that in a revolver computer science manner, which is, this is how you do for now. This is how it works for now. Just suck it up and live with the fact that this works. And then once you've gotten started, you go back and you actually look at why it works. We'll talk about why it works. But it uses double dispatch, which is a little complicated to wrap your head around until you've worked with it for a little while. Then it gets a little easier. So we need some way of traversing a parse tree and doing something when we hit specific nodes. So I have implemented And we'll talk about parameters and locals a little later, because the difference between parameters and locals and this stuff we just talked about now is that I don't know what the structure of the symbol table is going to look like, because that depends on how many curly brackets I have in my program. Whereas I know what the structure of these three things that can be forward referenced is. They always look the same. Normally it works when you hit things. Well, now I just broke it. You go into the utils directory. I'll show you the symbol table. There's not much to it. You can see it's the entries. It's just a hash table that maps strings to objects. And of course, I use this object here because it could be any kind of reference. I can create a new one that just creates a new hash table, empty. Let me skip this part right out, because I can also create a new hash table based on an existing one. And that comes in handy when we need to look at parameters and locals, because that way I can chain them, which is going to be necessary when I don't know what the scope is going to look like. I can put things into it, and I can get things out of it. And then I think you can print it out as well. That's pretty much it. There's some stuff down here, which we'll talk about a little later. So that's that. Did any of you look in this class called print visitor for this phase at all? Not at all?
Do we have access to this phase yet?
No, phase 2.
Oh.
Because the print visitor is the code that prints out the parse tree. And that is an implementation of the visitor pattern.
Very long.
There we go. You just have to,
Hit the right spot.
you just have to hit the table. Now it's all magic in here.
Too many lines
So-
to look at.
So we'll actually let me Emacs this one here. So this is some code that will traverse the parse tree and print it out nicely. You've seen the output from the reference compiler, the same as the output of yours. And it says public class print visitor extends visitor. So we'll have to look at what visitor is. But if you look at what this contains, it contains a whole bunch of small procedures called visit something, and that something is the same thing as it takes in as its first argument, and then it takes this generic object argument as its second argument. And then it does something. Here, for example, it says with a certain number of indentations, some blank, and then it says assignment. Then it adds 2 to indent, does something, subtracts 2 from indent, and returns null. So it prints something out and then calls something else. And if you go through this thing here, you'll see that it's the same all the way down. Basically, the one for block, well, it takes in a block, so obviously this is a reference to the block somewhere in the parse tree, and it just prints out, well, it prints out the line that the block is in, and then the word block. Increments the indentation by 2, and goes and does something else. So if you look at the thing, it's just, there's not much to it. It really just prints out all the information about every single node. So I implemented one of these visit whatever for every single node that could appear in the parse tree. It's just rather boring, actually. So the idea with the visitor pattern is that you start at the top of the parse tree. So if I have my parse tree here, then I say, go and visit the parse tree, and for every node, call the appropriate method in this class right here. So I'll maybe I'll draw a nice parse tree here so you can actually see it. Let's just take part of it. Let's have a class decal. And it has some children. One of them is a sequence of class body decals, right? So that could have a method decal. It could have a field decal. A method decal has a name, and it has a sequence of
Parameters?
statements. Well, yeah, that too, right? So these I just wanted statements, and it could have an if statement. Yeah, so it could look something like this. Now, let's say that I wanted to go through my parse tree and print out the word boo every time I see an if statement. I mean, it's rather silly, but you could imagine you wanted to do that, right? So, the task is print boo for every if statement. Okay, that's actually super easy to do, and I'll show you how to do it, and then we'll have to talk about why it works maybe a little later. But all I do is I say public class boo. Oops. Extends visitor. And then the rules are provide a method like, oh look, that was just pure luck that the if stat was right there. But implement a visit like this for every node you're interested in doing something with, knowing that if you don't re-implement it in this red visitor, then it'll just be skipped and its children will be visited. So this visitor thing will just sort of like flood through the tree, visit everything, but if you re-implement things in red, that method will be run instead, and you can get to do stuff. So all I have to do is have to re-implement this one here. So I say public object visit if stat is object art curly bracket system out print line boo, and then return null. I don't really care about the return value. The only thing I got to do is I have to put this line in here for things to work. This line here, you can see, well, what does this line actually do? If you just look at it, and I haven't shown you anything else, just look at that. What does that superduct visit if stat do? Well, it calls a method called visit if stat that is located where? In the superclass. So since this, like the red stuff over there, is a re-implementation of the visitor class, right? Then this will go and call visit if stat in the class that was declared as the superclass. So this will cause a call to visit if stat in visitor.java. And if I tell you that everything in visitor.java just visits children, then this will cause all the children to be visited. If I forget to put that line in, then I won't ever get any further down in the tree. So it's important that you remember to put that one in if you want to continue down. Now let's say, for example, you were collecting method decals. Then you need not to put this thing in because you can't have a method decal inside a method decal inside a method decal. But you can certainly have if statements within if statements within if statements. So they can be nested. So it's important that I continue down in the tree here. So all I do here is I say super.visit if stat is comma art. And now I have a piece of code that will print out boo for every if statement. Now you can imagine if I were to make this a little bit more complicated, and I went in and implemented visit class decal, visit method decal, visit constructor decal, and visit static initializer. Then I could do the appropriate thing there, right? So in the visit class decal, I would insert things into a class table. In visit method decal, constructor decal, field decal, and static initializer, I would insert those into the appropriate tables associated with the most current class that I visited. So that's what we're going to do. We have to work in two files. We have to work in one called class and member finder. And that one takes care of all the stuff that can be forward referenced. So that deals with classes, methods, constructors, and static initializers. And fields. Let me show you that file. Actually, before I do that, let me just show you what. Let me show you the visitor pattern real quick. And I'll show you why, what it does. So you can see that there's really nothing in it here, right? Look at it, and you can see some of them say something dot visit, and some of them say null. So here, for example, visit literal just says return null. Well, of course, that's because the literal is always a leaf node. It doesn't have any children. Here's an if stat. In order to visit an if statement, you have to go and visit its children. Now, how do I do that? I call is.visitChildren. What's is? Is is the if stat. So if I were to actually pull up the if stat, you'll see down here I have a visit method, and if I call up AST and go down at the bottom, it has a visit children. And remember, if stat inherits that from AST, so it'll have it as well. And what does this do? Well, it just goes through that children array and goes and visits them. So what you get, and there's a list or there's an address in the handout that points to a web page that illustrates this really well. What you get is you have a visitor that you set loose on a parse tree, and that visitor will call visit functions or visit children on the actual nodes, which will call visits in the visitor pattern, which will call visits in the nodes. So you get this sort of double dispatch ping pong back and forth. We can look more at it next time. I just wanted to get you started on this. But let me show you. So there's a directory called namechecker, which now you have something in, but you probably don't have much. There are three classes, right? Class member finder, myDecl set, this one you can ignore, and then namechecker. And the first one, oops. Class member finder. There's a whole lot more than I just sort of let on in it earlier. But the most important stuff is down. Well, let's see. So first of all, it's a public class and member finder, and extends visitor. Then I have some few methods in here that you have to do some work with. Apparently, it looks like I did all of the work. I'll have to figure that out. I should be doing some of it. You can see there's the constructor right there, and then comes your code. And I've done one here. I did the one for static initializer. So at some point, when I'm going through this big tree, I will hit a static initializer, and I know that the visitor pattern will make sure that this piece of code is called. Now, what do I need to do? I need to take that static initializer and enter into the method table of the currentmost class. And I have this global variable called current class. You can see if you look up here somewhere. Oh, so that's where it comes from. I actually take it in as a central parameter there. So that object there can be used to carry parameters around, and here I'm using that for current class. So I'm expecting when I visit a class Decl that it will pass as a second argument to its visits itself, so that I have the class. I can now take that object, turn it into a class Decl, and then use this add method above to enter that static initializer into the class, into the method table of that class. Now, how do you think the init is going to look? Well, it's going to look very much the same. How is method Decl going to look? Very much the same. How is field visit field deck are going to look very much the same, except it's not going to call add method, it's going to call add field. And the two methods, add field and add method, are up here. See, there's add method right there. And there's add field. I don't know why I seem to have filled that in. What are you supposed to write that? I don't know why I have to do all the work.
Such a nice guy.
Yeah, that's probably what it is. Well, I guess. Well, so you can see how difficult is it to do add fields. Well, I call put on the field table that's located in CD, which is the class decal, with a name, and F is the field decal itself. So, not a problem. And this is easy because I can't overload fields, so I can't have two fields of the same name. So that's not a problem.
On the map, right? It's a hash table, so it won't let you put duplicates.
Oh, no. So, I guess, I don't know why I wrote this for you, but we'll see.
Is that what's going to be open, or is that your version?
No, this is the handout, so I'm just going to have to look at it and see if I meant that to be there. So, this one class here, class implementer, requires you to implement 5 methods. You need to do something for methods, for static initializers, for constructors. That's all very similar because they all put things into the method table of the current class. You need to implement something for fields. That's somewhat similar because it calls add field instead of add method. And then you need to implement something for visit method decal, visit class decal, which will insert itself into the class table. And then of course remember to go and call the children. If you actually look at the bottom of this, the one that I implemented here, you'll see I actually don't have a super.visit. And the reason I don't have a super.visit is because I know that this static initializer cannot have fields, methods, constructors, or other static initializers below it in the parse tree because I can't nest those things there. So there's no need to go and visit those children. If I put in a super.call, super.visit static in call there, it will be perfectly fine. It will just go and traverse all the stuff that's below and do absolutely nothing and come back and say, okay, I'm done doing nothing. So I can cut off that traversal at this point because I know that there's nothing of interest right now further down. The next part, which is in the name checker, deals with locals and parameters, and I certainly can't cut off at this point because then I wouldn't deal with any of the statements that are in the body of the static initializer. But we'll have to talk about next time how we are going to set up scopes for the things in your program that allows you to redefine variable names. So for example, you can redefine a variable name when you have a set of curly brackets. You can do it when you have a for statement. You can do it when you have locals inside a method that has parameters. So there's a way to deal with that by building a chain of these symbol tables, and we'll look at that on Wednesday. And if you need me after 5, please send me an email.